Excellent. Well, thanks for taking the time off on a Monday, well, rather a Wednesday evening to listen to a Sydney sider, even though this is a DDD Melbourne event. But I figure in this day and age of COVID, I can sneak into your beautiful city events every now and then. I want to start off by talking about infrastructure code generally, what it seeks to solve, where it came from. The original reason of having infrastructure as code, or rather infrastructure declared as code, was to have repeatable environments on demand. And what this does, it basically hedges against environment drift, say between dev, UAT, and production. And the whole point of hedging against that environment drift and having our environments as close to each other is to minimize errors in downstream processes. For example, if we deploy to dev and then we promote into UAT and we promote into production, we want to know and have the confidence that each one of these environments is as close to each other as possible, so that if a defect is captured in dev or UAT, we know that the likelihood of it being captured in prod is high, so we won't promote into prod. So that's where this comes from. From a historical perspective, and certainly within the Microsoft ecosystem, PowerShell DSC desired state configuration was one of the first entrants into this infrastructure as code space. And things would get declared, resources would get declared within a virtual machine and Windows features and whatnot. And then slowly after that, as Microsoft released their Azure cloud platform, they also released what we call Azure Resource Manager templates. And Microsoft didn't do anything fancy here. They used an existing language, JSON, or if we'd call it a language or rather a data format. JSON is a data transfer format, similar usage similar to XML. And they use that for their templates. And through a bit of history and a bit of feedback and whatnot, Microsoft realized that ARM templates do have their issues. Specifically, JSON isn't built for purpose. JSON is a data transfer format. It isn't a language. As Microsoft developed these ARM templates and as they were being used, different vendors on the side or companies such as HashiCorp released their own infrastructure languages. So HashiCorp has Terraform. Some of you may be familiar with it. Specifically, the problem with ARM templates, and this is not something that purely from my own experience, although I have experienced it, it's something that Microsoft has received feedback on, is that it's clunky and verbose. As soon as you write a app service, a very simple website that connects to SQL, you have a file that is quite big relatively to your other files. So Bicep rather is Bicep is think of it as an evolution from ARM templates, and the name is a bit, I think they're playing on the whole, ARM and Bicep thing. And what Bicep is a language and a tool that transpiles down to ARM templates. What Microsoft did was they built a custom syntax. So they didn't use JSON, they didn't use C#. They developed their own syntax to declare infrastructure on Azure. And it's quite easy to install and now comes with the Azure CLI itself. And to give you a bit of a preview, if you were to deploy a Bicep file, you would simply type this into the Azure CLI. So the Azure CLI is very Unixy. AZ, got to stop double clicking, right? AZ deployment group create, you select a resource group, and the resource group within Azure is think of it as a bit of a scope and the template file. I want to run you through a bit of code and show you the syntax itself. So what we have here is a very simple app service or a website. And this is a platform as a service infrastructure website. And all it does, this template is provision that infrastructure so that you can deploy your application code, be it C#, Java, Golang, or Node.js. Now, Bicep is cool because you can also compile down to ARM templates as well. So if I did Bicep build and I selected that file, it has built for me a JSON, an equivalent ARM template. Now, for those of you who are familiar with ARM, if you were to do what you see on the left there with ARM, it would look something similar to this. So already we see a lot less noise, a cleaner syntax between what we see on the left and also the JSON that we see on the right. One of the key bits of feedback that came out of original ARM templates that were written in JSON was the ability to reference one resource from another, and also the ability to declare also the ability to clear up how dependent resources and the order of resources were to be provisioned on a Azure cloud platform. So what we have here in terms of the syntax is we have a declaration that something is to be a resource, followed by, think of this, they call it a symbolic link. Think of it as like a variable name. And what this does is it allows one resource to reference another. So for example, I have got a storage account here, and this storage account is referenced by a website, specifically my storage location. And in the site config, I've got an app setting, like a configuration that references my storage plus the blob endpoint. What this means is that when application code is deployed into this target, the website, the application code could just query this connection string, and on the infrastructure deployment time, the website will be linked to the blob. What this also means is that as soon as a resource is referenced by another resource, Bicep is smart enough to be like, oh, hey, because this website references my storage, I'm going to provision my storage first and then provision the website. What I'll do as well, I'll build this for you just to show you the difference. Excuse me, I opened up the wrong one. So we have on the left here is the Bicep, we have on the right is the equivalent ARM templates. So back in the day, oh, not back in the day, in ARM templates, the way one would reference another resource is using this syntax. So you'd have the reference function, the resource ID, and then from there, you'd be able to access the properties. We can see how long that is and how difficult, at least for me, this is difficult to read because of the recurring closing and opening brackets and the square brackets. In the early days of ARM, the tooling wasn't that good, so you wouldn't have these methods and highlighting and things like this, like going to the storage and being able to rename this. So all of the symbolic links that we see in Bicep are in fact part of the language. A lot of the tooling that has come through ARM isn't necessarily part of the language, but part of the tooling. So I've got a template here that is actually blowing some errors. Can anyone, without me hovering over, can anyone guess what that error might be?
Is it because you define the store? Oh wait, no, but the website one is having the error too.
Is it circular reference
or something?
Yep, circular reference. I don't know who said that, but that's exactly what it is. So this is something that in ARM I used to always get burnt by, but now as part of both the language and the tooling here, we say, oh yeah, no, you can't have this. There's a cycle. So if I even built this, so this is regardless of the Visual Studio Code tooling. Oops. Well, error. So that this is something regardless of the tooling. Another thing I want to show you all is outputs. So ARM templates also have outputs, but Bicep templates also have outputs as well. And because of these symbolic links, we're able to really just go properties as in the same way we would with F# or C#. We'd be able to reference properties of an object. The other thing I want to show you is string functions and string interpolation. Here, this syntax of string interpolation is, I mean, very kind of standardy. Like it's, I think in C# you put the $sign in the front of the text, but very easy to be like, oh, hey, like string concatenation, interpolation, whatever. We've got the website name there, and we attach to it that function of a unique string scope to the subscription, because websites have to be fully qualified domain names. And we also are able to pull location from the resource group target. So I want to show you how this actually looks like in ARM templates. I thought I could go through a whole talk with live coding without actually having an error. So back in the day of ARM templates, this is the way string interpolation would work. Not a very nice syntax. But one of the most powerful things I think with Bicep is the ability to make things quite modular and the ability for reuse as well. So what I've got here, I know it's a very simple example, but I just want to show you how I'm able to use a Bicep template twice based on parameters in a really simple format. So what I'll do, I'll open up the referencing template. So what I've got on the left is a declaration of a module. And what I've got on the right is the definition of that module. So the way it works is module, symbolic name, the path to the module, and then the parameters. And these parameters are here. And because this file here on the right has an output, storage account name, I also have a hook into that storage account name as well from the declaration of that. So we can build quite modular ways of doing things. One gotcha with Bicep though is target scopes. So a common scenario that I have seen is the need to say provision a hub VNet or a spoke VNet on the specific subscription. So a good way to get around the issue of having, say, one deployment that provisions a resource group scope to the subscription, and another deployment that provisions the virtual network inside a resource group is what I'm about to show you here. So the reason why doing two deployments for that isn't necessarily the best thing, because you almost want one error message if either of these things fail. So what I've got here is a template that is the target scope, a subscription. And for those of us who aren't that familiar with Azure, Azure has several deployment scopes. We've got resource groups, which is the most common one where we deploy resources. We've got a subscription under it, where it may have multiple resource groups, and a subscription is a cost level categorization. And then on top of that is a management group, which has several subscriptions. Now, in this particular case, this whole template is scoped towards a subscription, and it provisions a resource group. But a virtual network can only be deployed within the scope of a resource group. So I'll repeat myself because it's even confusing to me saying it. A resource group can only be deployed for deployment with a target scope subscription. A virtual network can only be deployed into a target scope, which is a resource group. So what this template actually does is that it provisions a resource group, and then it takes the resource group that's just been provisioned and creates it as the scope for the virtual network deployment. And this is a simple virtual network that'll just get set up with the default NSGs and whatnot. And this allows us to do things like setting up whole subscriptions with your networking and with your peering, all that funky stuff, and landing zone stuff quite nicely together with the modules. So finally, I'm probably going to be a bit more opinionated than Nick here. I would encourage you all to give Bicep a crack. I know that it is the natural successor from ARM, and yet there is always that conversation, you know, if our environments are in ARM, is it worth going to Bicep? I understand that, but it is ready for production as of, I think, maybe a month or whatever. I can't remember. And also use the ARM documentation, because the same ARM documentation that you have been familiar with, or that some of you may have used, is able to be used with Bicep as well, because essentially Bicep transpiles down to ARM, and ARM's been around for ages and has a large community. The syntax is easy and the tooling is really good. I think the plugin I'm using here, I literally just searched Bicep and I got the plugin. It's pretty easy. And finally, there is a growing community both on GitHub and Stack Overflow, so I'd encourage you to auto use it. So thank you. I hope that was under 10 minutes, and I'm happy to take questions as well.
Raf, there are a few questions in the chat if you would be kind to answer them.
Sure.
I think you just already answered the first one.
Circular reference, Raf. Do you know whether Bicep scripts get converted to an ARM template and then executed by Azure, or whether they get directly executed? So that's Raj. Raj, what happens is that, yeah, they basically get executed into ARM templates, and then they get executed by Azure. So even if you were to do something like this, that actually generates an ARM template and deploys that ARM template to Azure, even though you might not see it in your file system. I might go on a bit of a tangent, but I think Microsoft is trying to use ARM as like a middle language for their Azure deployments, because they just released this other thing called PowerShell ARM or PS ARM that also converts things to that converts PowerShell to ARM and then ARM to be deployed to Azure. Circular reference. Oh yeah, cool. The definition doesn't even know that's being used like a malicious node. Raf, does Bicep have any limitations on the type? No. Anything that's accessible by ARM is accessible by Bicep. Can you reference the output of an existing deployment without it being part of your current deployment? Like, if person A deploys with Bicep and lists an output, and then person B wants to do a separate deployment that references an output from person's A deployment, can it handle that? Curtis, is that related to two different deployments?
Yeah, I'm just thinking if you got like different teams that are deploying microservices and stuff. Yeah, so you don't want to have one deployment that does the whole stack. You've got like team A does theirs and team B references team A's deployment.
You would need to save the output in an intermediary tree, like somewhere.
Okay.
Yeah, because that output is dynamic.
You could do it through Azure PowerShell or Azure CLI. You can query the previous deployment and get the outputs from there and use it in your
Yeah. So at the moment, I'm doing stuff in AWS, and they they call them stacks, and stacks can have outputs, and you can reference the outputs of other stacks from any deployment, which is kind of handy. They just uses the current output of the most recent deployment to that stack.
Yeah, so because the outputs, I don't know, sorry, I probably failed to mention this. The outputs are essentially JSON. So you can parse the outputs. You can use any of your favorite scripting languages, Python, PowerShell, Bash, whatever, to parse the outputs and then use it in anything you want. So I don't know, in your scenario, like if you want to do like multi-cloud strategy thing, you can deploy, say, a storage account using PowerShell, parse that output using JSON, and then use that same storage account and credentials into CloudFormation or something into AWS.
Okay, I think that's it for the questions. You're going to still hang around if anyone wants to send more questions. But yeah, thanks very much.
Thank